Hi, in this video we'll learn about control your learning. Pause, rewind and replay. Take great notes. Download the lesson template at mathfolio.com/vidsheet. Let's get started. Okay, so to get started with rates, ratios and proportions, take a look at some of these pictures. All right, so what does all of this stuff have to do with ratios and proportions and rates? Well, let's go back to this unordered bunch of M&Ms. Okay, let's take a look at this. Ratios are a comparison of two amounts. So here, if we were to organize them, we would see that there are 4 yellow M&Ms and 3 red M&Ms. The ratio of red to yellow M&Ms, then you could say, well, that's 3 to 4. Now, there's other ways to write this ratio. You could write it as a fraction, 3/4, or you could write it as also using the word 2. So 3 to 4. So that's pretty much what a ratio is. It's a comparison of two amounts. Alternatively, if you were asked for this ratio as what is the ratio of yellow to red, then you would in fact say that ratio was 4 to 3, or 4/3, or 4 to 3. And another thing that you may be asked for is, what is the ratio of red to all, or red to whole? Now in this case, the red is 3. There are 3 reds. And to all, well, if you count them all up, there's 7 total. So that would be 3 to 7, or it would be 3/7, or it would be 3 to 7. So that deals with ratios. Very quick introduction. If we understand that a ratio is a comparison of two amounts, then what's a rate? Well, rate and ratio are sometimes synonymous, and people use them both to describe the same thing. Really, a ratio, not only is it a comparison of two amounts, but usually ratios have the same units. Now, we actually break this rule all the time. However, just keep that in mind. If we're being strict, a ratio should have the same units. Just like those M&Ms, they were all M&Ms. We had 3 red and 4 yellow. Same units. It's a comparison of two amounts that have the same units. Whereas a rate is kind of comparing amounts with different units. So for example, a rate we might have, we're traveling at 30 miles per hour. So that would be our rate. And in fact, because here, this is 1 hour, per hour means 1 hour, that's implied, this would in fact be a unit rate when it's per 1. A regular rate would be something like, I could do the same unit rate, but write it slightly different. I could write 30 miles per 2 hours. Now, because this is not per 1, it's not a unit rate, but it is a rate. Okay, now if we connect these two, we could in fact make a proportion. So a proportion is 2 equal ratios, or in fact rates. Let's make this a 2. That's what a proportion is. So for example, 30 miles per 1 hour is the same as 60 miles per 2 hours. That's a proportion. Let me just give you one other example that might help come to grips between ratio and rate. Let's say we got this person here and they have 5 hot dogs. Okay, and then we have another person over here, and they have 10 hot dogs. Now, in this case, what we can do is we can look at this situation and we can say that the ratio of person A to person B, the ratio of their hot dogs are 10 to 5. That's the ratio. Now, that's comparing two amounts, and also they're the same units. That's the ratio. But let's say that this first person, person A, can in fact eat 10 hot dogs per minute. So 10 hot dogs per minute, and the second person can eat 5 hot dogs per minute. So whatever they have in front of them, they can eat that amount of food per minute. Now, both of these, we could think, well, isn't that 10 to 1 hot dogs to minutes, and this is 5 to 1 hot dogs per minute. And people treat those as ratios, but really, if we're being strict about this, because it's an amount per other amount and they're different units, this would in fact be a rate. So in the first case, we're comparing hot dogs to hot dogs, part to part, and so that's a ratio. In the second case, hot dogs per unit of time, hot dogs per minute, and so that's a rate. Okay, so very quickly, we're just going to look at some words and talk about the definitions. We've already looked at these a little. Rate, this is a frequency, an amount of something per something else. So for example, miles per hour, hot dogs per minute, words per second, those would be rates. Also a unit rate. Unit rate is when it's per one. So miles per hour means per 1 hour. Also, words per minute, per 1 minute, that's also a unit rate. Ratio is a comparison of two amounts, and if we're being strict, they would have the same unit. Proportion is two equal ratios, so that's when we're really setting up two fractions, and we would let them both equal each other, and then often we can solve to find one of the missing values. Another word that's connected is percent. So percent we know with the sign, but percent means for each 100. So if we talk about an amount of 5%, that would be 5 per 100. So 5 per 100 is 5 over 100. Another key vocabulary word, cross multiply. And so in a case where we have x over y equals a over b, we can multiply the y and the a together and the x and the b together, and we can end up with ay, that's a times y, equals bx. And then we could solve from there if we had some numbers here. Another word to keep in mind, quotient. So quotient is the result of a division problem. And also the words solve and evaluate, those mean find your answer. Okay, so here is the first example. So I've got one bag of M&Ms and my friend has 3 bags. Inside my bag, I have 4 blue M&Ms. How many blue M&Ms would you expect your friend to have in total from 3 bags? Well, we're going to make assumptions here. We're basically assuming that in each mixture of different colors in each bag, that they're pretty much the same, which might be a fair assumption. I don't know how their factory works. We're going to assume that it's roughly the same. Okay, so we see in the picture that over here that we have got these 1, 2, 3, 4, and they came out of this bag right here. So therefore, just thinking this through, maybe there's 4 there, there's 4 there, and there's 4 there. So in total, if we add them all, that would give us a total of 12. And 12 would be the answer that we would expect 12 blue M&Ms to be in these bags. But this is the sequence that we can use for all proportion problems. So I'm going to show you that right now. First of all, we look in the question and we try and identify what comparison we have. So in this case, it says I have one bag, and inside my bag I have 4 blue M&Ms. So again, one bag yields 4 blue M&Ms. So we've got bags and M&Ms. So this is the key, the legend that we're going to set up here. So in the first case, I had one bag and it gave me 4 M&Ms. So notice how I've set this up. This is hugely important right now. One bag, 4 M&Ms. Then we keep going. Let's switch the color over here. So now the friend has 3 bags. So we're going to put the 3 on top over here. So we're trying to come up with our 2 equal ratios, okay, to create a proportion. So 3 bags, and it says the question here is actually saying how many blue M&Ms would you expect from the 3 bags. So how many, we're going to put an X in line with the M&Ms. So once we have this proportion, what we're going to do now is just cross multiply. So the X times 1 is 1X, or just X. The 4 times the 3 is 12, and that's our answer. But we should always go on to write our answer. I'm going to use 3 dots for the word therefore. That's a symbol in math meaning therefore. We could say I'd expect my friend to have 12 blue M&Ms in his 3 bags. So that would be question number 1. Okay, so this is example number 2. In New Zealand, the ratio of people to sheep is 1 to 20. So I guess this is the people, the 1, and then the sheep is this 20. If the number of sheep and humans total 63 million, how many sheep? So the question is looking for how many sheep are there in New Zealand. All right, so there's a little twist in this problem. The twist comes right here when it talks about total. Because so far, the start of the question just gives us a ratio of people to sheep. So people, sheep, 1 to 20. But towards the end of this, we've got the total is 63 million. And we want to know how many sheep there are. Well, so far we can't let 1 over 20 equal X over 63 million because this is a person per sheep and this is a sheep per total. So one thing that we can do is try and get this ratio here, the 1 to 20, in the same format as sheep per total. Well, if you imagine that this is a small sample right here, this is the basic ratio, 1 to 20. Well, what would be the total in this little group here? Well, the total would be the 1 person and the 20 sheep. So the total would be 21, and the sheep would be 20. So that would be the ratio of sheep to total. So this is a part to whole ratio. So now what we can do is we can compare these 2 ratios and set up a proportion. So let's do that right now. So we've got sheep all over total, and this is crucial to always set up this ratio to stop you from flipping one of the ratios in the proportion and getting it the wrong way. Now it doesn't matter if you put total on top and sheep on the bottom, but you must be consistent. So I've got sheep on top, so it should always be sheep up there. So the basic ratio that I've got is 20 sheep compares with 21 total things. So that's the sheep and the people. And I'm going to let that equal X, the number of sheep, per 63 million. Now, cross multiplying here would work, and you could definitely do that. But there's also a method that's called scaling, and sometimes it's easier to see scaling than other times. Well, just look at the 21 and the 63. Forget the million over here. Just look at a 21 to 63. How many times can we multiply 21 to get 63? Well, times by 3 works. So if we wanted to get 21 to become 63 million, we would times by 3 and then times by a million. And that's the same as timesing by 3 million. So if that's how we can go from 21 to 63 million, by timesing by 3 million, that works on the top. We do exactly the same. We scale it up. So we're going to times by 3 million. So 20 times 3 is 60, and then put the million. So x equals, what do we say, 60 million. So basically, this is true. That means that there are 63 total humans and sheep in New Zealand, and out of those 63 million, 60 million of them are sheep. And so the difference between the 60 million and 63 million means that is 3 million people and 60 million sheep. Wow, pretty crazy. Example number 3. According to the American Community Survey just a few years ago, 13% of the US population report British ancestry. So that's either full British origins or just part British, but they have some British ancestry. If the population of the US is 310 million, how many are British American? So assuming that they're going to identify as British American if they have British ancestry. So here, this is a nice example because it's our first percent. So let's take a look. We've got 13% have British ancestry. So this percent can be written as a fraction. 13% means 13 for every 100. Now, we set up a proportion by letting that equal. So this is the British ancestry, and this is a total. So we're setting up our key on the side. 13 out of every 100 report British ancestry. Now, we want to know how many for real are British American out of a total of 310 million. So 310 million goes as our denominator, and the number we're trying to find goes on top. Now, again, we could consider how we scale this up. That would definitely solve it. But you know what? Let's not do that. Let's just cross multiply and do it this way. So I'm going to change color. I'm going to say x times 100 is 100x. We're then going to do 13 times 310 million. Let me just make sure I got the right number of zeros. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Okay, so we're dealing with 4 billion, 30 million. Now, next step, divide both sides by the coefficient of x to get rid of it. Divide all of this by 100. So this 0 for this 0 for this. So we end up with x, which is the number of British American, equals 4030,000. And if we put the commas back in there, that means that roughly 40 million people that completed the survey consider themselves British American. So you could put that people are British American. All right, so those were our 3 examples. Okay, so this is our first question and answer. All right, so as you see, I partway filled it up, and it shows that the 0.375 gallons are in the tank, and at the moment it's going to cost me $1.20. So the rest is question, how much will I end up paying when I fill it up with 0.568 gallons? So press pause, give it a shot. All right, so the video shows us the answer, but let's try and calculate it right now. I'm gonna grab the blue pen. Alrighty, so we know that we have a cost per gallon. So cost and then per gallon. Well, we saw as it was part way, we were showed that $1.20 gives us 0.375 gallons. And we were told that up here, we need 0.568 gallons, 0.568 gallons, and we wanted to know the total cost. So this becomes our proportion right here in the red. We have 120 over 0.375 equals X over 0.568. Again, if we cross multiply right now, we've got X times by, really should put the coefficient first, so 0.375x equals 120 times by 0.568. To get the X on its own, divide by 0.375, divide by 0.375. So I'm going to grab the calculator, do the work. So that gives me an answer of 1.8176. So if I'm going to round this for the actual price, because it's money, I should probably stop right here. So it's going to be $1.81. But really that 7 is going to round it up. So therefore that's not the answer. It should be $1.82. Now it's asking for the unit rate as well. So the unit rate is the price per gallon. Now in this motorcycle, I've had to put in super and not regular. So that unit rate is going to be the amount that's displayed on the sign, because that's a price per gallon. But we should be able to calculate it from here. If we take this first amount here, that it was $1.20, and that was the cost, and that was per 0.375 gallons, the unit rate is per 1 gallon. So we're looking at the cost per 1 gallon, which is this. And again, we could cross multiply here, but really just to get the X on its own, X over 1 is X. So therefore, X is just going to be the 1.2 divided by 0.375. So that gives us a price of $3.20. It comes up as 3.2. So the unit rate is $3.20 per gallon. And that's the price. Now, one of the things you might notice in the video is that the price shows on the display as $3.19, but then there is the 9 over 10 that's after that. Now that 9 over 10 really means 9/10 of 1 penny. And it's something that they have on most gas stations. They seem to have that at the end of all the numbers to make a little more money, to make it seem a little cheaper. But yeah, so for all intensive purposes, $3.20 per gallon is the same as $3.19 and 9/10 of a penny. Okay, so this is Q&A number 2. So pause it, try it yourself, and then come back for the answer. So in this case, brother paid this much for this much. So we've got the cost and we've got the pounds. He paid $1.58 per 2 pounds. If I shop at the same store, how much would I pay for a bunch of bananas weighing 3.2 pounds? So 3.2 goes on the bottom. How much? X goes on the top. So again, this is my proportion. Got the fraction here, fraction over there. It's 2 equal ratios, or in this case, technically rates, because they're not the same units. Cost is dollars, weight is pounds. But from this point, we could cross multiply. So 2 times x gives you 2x. And then we've got 1.58 times by 3.2, whatever the answer is. And now to get the x on its own, we're going to divide by the 2. That kills off this. I'm going to put the divide by the 2 over here. So now x equals, if I do all the math, I got 1.58. So that gives me an answer of 2.528. This is a dollar amount. Now this goes beyond a penny, so we need it to stop right here. So therefore the answer is going to be $2.53 because the 8 is 5 or more, so it pushes that 2 up to a 3. So $2.53 is the answer. So let's take a look. So we've got the first statement that we're told is 90 minutes, 2 walls. So that's our comparison of 2 amounts. So we've got the time and we've got the walls, the number of walls. So one thing to look at here is that the time here is in minutes, the time there is in hours. So we've got to be consistent here. Time, because 90 minutes is an hour and a half, I would probably keep this in hours. So we've got 90 minutes, which is 1.5 hours, gives us 2 painted walls. That's our first ratio, or technically a rate. And that equals how many walls? That's going to be x over here of the same size. Can I paint in 4 hours? So hours would be 4 this time. So this is our proportion. This time the quantity we need, number of walls, is on the bottom. If we'd have set up walls on top and time on the bottom, it would have been flipped, but this is fine. Let's cross multiply. So x times by 1.5 is 1.5x. 2 times by 4 is 8. Now I got 1.5x equals 8, so we're going to divide by that coefficient. So we've got x equals 5 1/3. So the answer would be how many walls of the same size. So you can paint 5 1/3 walls, really of the same size, in 4 hours. And that's our third Q&A. For the Your Turn section, this is where we won't go through any answers. All 6 questions will be shown on the screen. You should pause the video and then attempt all 6 of them. If you're working through the lesson template at mathfolio.com/vidsheet, then there's room on that template to show the work and to put all your answers. And the same with the monster section. That's going to be one big question where no answers will be given. And you are invited to show all your work on your paper, maybe submit it to your teacher, or if you have a study pal, to compare answers with them. Okay, so here are the questions. Okay, so don't forget, pause this video now and attempt these questions. So next is the monster question. This is where you'll be expected to do many of the skills that we've been working on. Some of them might be combined, and this will be a pretty tough question. If you can do it, then you pretty much have this topic covered. Here goes. Okay, so hopefully you press pause and gave it a shot. If not, go back, attempt it again. That's it for now. If this video's helped, give it a thumbs up and leave a comment below. Also, subscribe for more videos. Thanks for watching.